So that position vector r is irrotational. A vector is said to be irrotational if its curl is equal to 0. So here we will find the curl of the position vector. If the curl of the position vector is equal to 0, then it is proved that position vector is irrotational. Suppose the position vector r is given by I cap x plus j cap y plus k cap z. Then what will be the curl of the position vector r? Curl of the position vector r is equal to cross product of del of r. If you take the cross product of the position vector with the del operator, then that will be the curl of the vector r. We know del operator is a vector operator, and that can be defined by I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z, and the cross product with the r vector. So the r vector is I cap x plus j cap y plus k cap z. If you take the cross product, then that can be written in determinant form like this, that is I cap j cap k cap partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z. Then for this position vector r, you have x, y, z. And if you take the determinant, then that will give you the curl. So let us find out the determinant. If you find out the determinant, then for this column and row, that is I cap, you have partial derivative with respect to z, partial derivative of z with respect to y, the first term, minus partial derivative of y with respect to z, the second term, minus j cap, the second term, into partial derivative of z, this one, partial derivative of z with respect to x, minus partial derivative of x with respect to z, this one. And for the kth term, you leave this row and column. So you have partial derivative of y with respect to x minus partial derivative of x with respect to y, this one. So if you take the partial derivative, you see partial derivative of z with respect to y, this will be equal to 0. Similarly, partial derivative of y with respect to z, this will be also equal to 0. Similarly, partial derivative of z with respect to x will be 0. Partial derivative of x with respect to z, 0. These two terms also 0. Partial derivative of y with respect to x, here partial derivative of x with respect to y. So the final result is equal to 0. So here we proved that the curl of r, that is position vector, curl of position vector, we found that is equal to 0. So position vector r is irrotational.